All right, how's everyone doing today? All right, I want to play this really fun social experiment. So if you have an empty seat next to you, can you move in? Because I got here this morning a little bit late because my flight was delayed because air travel is terrible. Thanks, Adam left. And there were a bunch of people sitting on the floor in the back, and that makes me sad because there were empty seats in the middle, but they couldn't get to you. So I know how much you love sitting on the end, but if you could just take a shuffle into the middle, that would be really great for the folks who are going to filter in late. Look, give it up for those folks over there. See, they're making new friends. Thank you for doing that. So it's actually relevant to this talk because this talk is focused on Terraform, which is a tool for provisioning infrastructure as code, but it's really rooted in this concept of collaboration and openness. So who am I? My name is Seth. I'm a developer advocate at Google. You might recognize my name from HashiCorp. You might recognize my name from Chef or Custom Inc., all of which are represented here today. 3 of my managers are here, past managers are here, so that's exciting. And only one of them is also named Seth, so that's cool. You can tweet at me. I'm Seth Vargo pretty much everywhere on the internet. So feel free to say hi. If you have questions, feel free to reach out. My job at Google is to engage with the DevOps community. So that includes the tools in my basic entire career path, so Chef, Puppet, Ansible, Salt, Terraform, Vault, Nomad, Cloud Foundry, all of those things. So if you have any questions about those tools or how they relate to Google, please find me. So obligatory definition slide. What is collaboration? So this is my definition, slightly adapted from the Wikipedia definition, which is 2 or more entities working together to achieve a common goal. And notice that I didn't say people, because robots can collaborate. There's this really cool video of 2 robots that look like dogs trying to open a door for one another. So we're at a world, and it's an exciting world, where collaboration doesn't just happen between humans, it happens between entities. But the important part is that you work together to realize or achieve some common goal. So if 2 kids are on a playground, and they're working together to try to do the monkey bars or solve some type of problem, that's collaboration. But if 2 people are working against one another, that's not collaboration. Even if they're working together, if they're working against a common goal, or they're working towards different goals or ulterior motives, that's not collaboration. So there are some really interesting benefits to collaboration. And this comes from like a number of studies. If you want all of the white papers, I can send them to you or tweet them out. But a number of different studies have found that increased collaboration leads to things like more engaged employees at meetings and in the company, more productive meetings, accelerated business velocity, better profits, things like higher employee retention rates, expanded diversity for both hiring and existing diversity within the company, etc. So there's a ton of information and a ton of supporting evidence and a lot of people who have PhDs and are way smarter than I am who say that collaboration is really good. There's actually very few trade-offs to collaborating, really other than time. So if collaboration is so good and there's all of this supporting evidence that says we should collaborate with one another, why aren't we? There's so many cases where people go off on their own and do things without talking to people. They go down in a little hole or go off and do a sidebar and come back. And it really breaks down into the requirements for collaboration. So this is where I start presenting my opinions as fact. That was a joke. I think there are 5 key requirements for collaboration. Yes, there are only 4 things on the slide. Time. So the number one reason that people don't collaborate is they just don't have time. How many people have ever looked at a problem and said, it's far easier for me to solve this on my own than to try to explain it to someone else? That's true. It happens. I've done it. That doesn't make you a bad person. It's life. The second collaboration requirement is trust. How many people have ever not wanted to collaborate with someone because they're unsure that that person would have the right means or motive to complete the task, right? If I'm about to build this new startup, this hip new technology, I can't just bring in anyone. I have to bring in someone that I trust. Another collaboration requirement is diversity. Can you collaborate with yourself? It's actually really hard. If you have a bunch of like straight cis white dudes in a room, they probably don't have different ideas. So collaboration isn't as relevant. However, when you bring different ideas to the table, race, gender, age is one of my favorite diversity categories that people forget about. You have different perspectives. And those different perspectives lead to things like accelerated business velocity and all of those other great things. But if you don't have diversity, collaboration is pointless. You can collaborate, but you're not bringing new ideas to the table because everyone has the same shared experiences. And you also have to have incentive. If there's no reason to collaborate, whether it's you're going to get a peer bonus or you're going to get this thing to market faster or your company's going to pay you, there's really, without an incentive, it is extra work, right? It requires time, it requires trust, it requires this investment that if you just went off and did it on your own, you wouldn't have to do. So to that end, you need some type of incentive. But there's a fifth pillar of collaboration, which is really what this talk is about today, and that's that collaboration requires a shared language. And this is something that I think is often overlooked, and it's the crux of this talk today. Shared language is important. If we're not speaking the same language and using the same words and the same definitions, it's very difficult to have a conversation. So for example, I could give the rest of this talk in Spanish. And it would be very unlikely that many of you could follow along. I could reduce the percentage even further and give the rest of this talk in Arabic, and even fewer of you would follow along. And that doesn't mean that the conversation I'm having isn't valuable. It just means that we can't collaborate. We're not speaking the same language. I could give this talk in binary, and many of you would follow along. But the simple fact of the matter is that without a shared language, without a consistent way to describe things and to communicate, we can't collaborate effectively. We might get through it. We might be able to use technology and real-time translation, but having a shared language and a shared dialogue is a key component of collaboration. So I know what you're all thinking. Like, I came to this Terraform talk. And he's not talking about Terraform. What is up? So I have on this fun slide, and I'm going to show you a slide, and it's going to have a bunch of text, and you're not supposed to read it, so please don't squint. This is descriptions of infrastructure from 3 major cloud providers, Google, Azure, and Amazon. Do they look like the same language? There's 1 JSON and 2 YAMLs, but the schema for those YAMLs and the schema that matches that JSON is completely different. The Azure template is 150 million lines. It doesn't even fit on the screen. I had to truncate it. We actually don't have a shared language to collaborate on infrastructure if we use cloud provider-specific technologies. And that's what I want to talk about today, is that if we want to collaborate on infrastructure, we have to speak the same language. It's a key pillar of collaboration. If we don't have a shared language and a shared understanding, we can't communicate effectively. And then there's a whole bunch of benefits that come with having that shared language, some of which are collaboration, but there are others. And that's really what Terraform is designed to do. So you can look at Terraform as this really cool technology that uses graph theory under the hood and is written in a cool, hip new language. But really, at the end of the day, Terraform is a tool that provides an abstraction so that you can collaborate. That's the elevator pitch for Terraform. It's a tool that provides an abstraction so that you can collaborate on infrastructure as code. And how does it do that? Well, Terraform has its own language specification. So I know the XKCD comic that's like, there are 12 competing standards. We must make one unified standards situation. There are 13 competing standards. But what's great about Terraform is that many cloud providers are seeing the value in having this platform agnostic way to describe infrastructure. So for example, at Google, we have an entire team of people who work on Terraform full time. So yes, Google has a tool called Deployment Manager. It's similar to AWS CloudFormation. It only provisions Google resources, but at the same time, we see value in having this tool that is a shared language across multiple clouds and multiple resources as a thing that is supported. So to rephrase that, Google pays people full time to work on this open source tool so that it works well with our cloud. Same thing with Amazon, same thing with Azure. Because we have this shared language and this shared understanding, we can describe resources in a very simple way. So this is Terraform syntax, and my goal of this talk is not to teach you Terraform. There are workshops and all kind of other stuff for that. My goal is to get you excited about a new technology or a potential solution to one of your problems. So this is how I might define a compute resource for Google Cloud using like a Debian 9 base image. And this is obviously kind of Google specific. But when we compare this to, say, the three major cloud providers, Google, AWS, two cloud providers, Google, AWS, and DigitalOcean, you can see that even though the implementation details are different, right? One is AMI equals, two are image equals, the language is the same. And I call this dialect, right? We're in the South here, so I'm supposed to say y'all, right? If you come up where I live in Pittsburgh, we say yins. If you go up north to Boston, we say yous. And that doesn't mean anyone is right or wrong, but you really shouldn't say any of those. But the fact is that it's a dialect. And just like in English and Spanish and Arabic, there are dialects, right? There are entire professions that can, linguists who can listen to what you say and pinpoint where you grew up and where you live. There are dialects that come with these cloud providers, right? What is an Amazon AMI, what is that, A94BC3 on Google? It's not really a thing, right? There's no mapping between those. And that's a dialect, right? That's an implementation detail of Amazon. And the same thing is true, like the Google Compute instance for Debian 9 is different than the Ubuntu 16.04 base image for DigitalOcean. Well, what matters is that we have this same language that we're speaking. So when someone comes to the company or joins the company or switches teams, they can easily see what's going on in this declarative syntax. So to recap, each what we call provider, so each cloud or each provider has these resources, and these resources have dialects, but we're using the same language. We're using this configuration language, and because we have this common ground, there's a lot of cool things that we can do. For example, we can compose resources. So when you think about a traditional web application, maybe a blog or something, I might have my front end, my WordPress website, and then a DNS entry, for example. And there's an order of operations there. I actually can't create the DNS entry until after I've provisioned the instance because I don't know its IP address yet. Right? There are certain things that are only known at creation time. And in this simple example, I know I'll just create the WordPress site, get the IP address, copy and paste the IP into something like Cloudflare, and I'm done. But when you think about managing infrastructure at scale with hundreds of thousands of machines, you can't reason about the complexity in the order of operations. And it gets even more complex when you think about how does changing this one server affect the existing fleet? What is the rollout effect? So Terraform allows you to compose these collections of resources and creates a dependency graph between them. You'll also notice that Terraform is supporting non-traditional infrastructure resources. When we say infrastructure, we generally think of like compute, storage, and networking. But there's a lot more to infrastructure. So here, Fastly is a popular CDN. So here we're configuring a CDN as code, a content delivery network as code. We can also manage things like DNS. Or one of my favorite things to manage with Terraform, and this is a thing I actually do, like this is how I manage my GitHub teams and permissions, is with Terraform configuration files. So instead of clicking in the GitHub UI or writing something with OctoKit, Terraform integrates natively with the GitHub API, and I can define my organization, my repositories, the permissions on those repositories, team memberships, etc. So here I have a GitHub team that I've named admins, and I'm adding myself as a maintainer to that team in my organization. And what you'll note is that Terraform uses this really cool interpolation syntax that's bold on the screen, that $curly brace. What that does is that tells Terraform, take the ID of this thing, which I don't know, GitHub's going to generate that. I have no idea what that's going to be, I can't predict that, and put it in here, interpolate that value. As a human, you look at that and you're like, okay, I know what this is doing. Terraform as a machine looks at that and says, oh, that's a dependency graph. It looks at that and it says, I need to create the GitHub team named admins before I can create the GitHub team membership linking to that admins, because it doesn't know that ID attribute until after the resource is created. So in this way, Terraform will parallelize the creation of these resources. So if you imagine you had 100 team membership entities, Terraform would create the team first, because all of them would depend on that team, and then it could create the memberships of those teams in parallel, handling failure and rollback. So this interpolation syntax is really powerful in that you don't actually have to think about the order. So how many people have ever worked with Puppet before? Okay, so when you work in Puppet, Puppet also uses a DAG, a directed acyclic graph, to define the order of dependencies. But with Puppet, you have to actually explicitly say, do this before that. So you have to think about the order of operations. With Terraform, the interpolation syntax does that automatically. So you don't have to think about, should I do this before that? If you use the interpolation, Terraform will make the right decision. And one of the coolest parts about Terraform is the separation of the plan and the apply phase. And this is where it comes back to collaboration. So we have this shared language. We have this really cool technology under the hood that consumes that language and produces resources and artifacts. But that's still not getting us to the right level of collaboration. Instead, we need a way to be able to treat our infrastructure as a text file so that we can treat our infrastructure the same way we treat our application code. So just like today, you probably have a Jenkins pipeline or a CI pipeline of some sort that takes your build artifacts, runs tests and integration and unit tests, and produces a build artifact, and then you ship that to production at some point. We need to be able to do that with infrastructure too. And the way we do that is by capturing infrastructure as code. Terraform separates the planning from the apply phase, so you have a true unit and integration style test for your infrastructure before you provision it. And we can collaborate and put checks and gates in between the planning and the apply phase. So what Terraform is going to do is whenever you give it some infrastructure, it's going to first predict the series of steps it will take. It'll present that to you in the form of a plan. It'll say, hey, here's the actions I'm going to take. I'm going to create this, I'm going to delete this, I'm going to update this. Then you have to approve that plan. And as an organization, you can require multiple people come in and approve a plan. So it's not just one person going YOLO. Instead, you can have multiple people who look at that output and say, yes, this is something that makes sense, or no, please don't do this. The apply action then goes out and executes those changes against the cloud providers and the third-party resources. So by using a common language, we can treat our infrastructure the same way we treat our applications. If you read the abstract for this talk, I said it was all about theft. And I still stand by that. Infrastructure as code is a way to steal everything that application developers have had for the past 15 and 20 years. Code pipelines, linting, CI/CD, staged builds, canaries, all of these things that we talk about in the application development lifecycle. Infrastructure as code is not reinventing the wheel. Terraform is not reinventing the wheel. Instead, it's giving you a technology that lets you leverage those existing pipelines, those existing processes, and those existing workflows so that you don't have to reinvent the wheel. But now you can treat your infrastructure the same way you treat your Ruby app or your Python app or your Java application. So I have this slide that says demo time. So I suppose I have to do a demo. So let's try this. Is everyone with me so far? I got one, yeah. Okay. Perfect. It's 3%. All right, so new MacBook Pros, really great. All right, can everyone see this? Okay, so make this a bit bigger. So I have these Terraform configurations that I created in advance, and they're really simple. So again, my goal of this talk is not to teach you the in and outs of Terraform, it's to get you excited about a new tool and technology. So this is my Terraform config. It has two things in it. The first thing is go talk to Google. So I've declared my provider, in this case is Google. That could be Amazon, that could be AWS, that could be DigitalOcean, or you could have all of them in the same file, right? You can integrate with these providers simultaneously. I could use the output of, say, a Google Compute address and assign that to a DigitalOcean droplet through a load balancer if I wanted to. Next, I'm creating a Google Compute address. This is just a this is a regionally available IP address that anyone in the US East region will be able to hit this IP, and I can route that to whatever I want to do. It's not that exciting, but creating a compute instance takes like 2 minutes, and I don't have enough talk to sit here for 2 minutes, so this is like 10 seconds, so it's just a cheat. But there's a number of resources that you can create. There's over 100 of them actually for Google and Amazon and Azure, et cetera. So Terraform separates the planning from the apply phase. So the CLI is Terraform. It's a single static binary, but I suck at typing and I'm lazy. So I'm going to use TF as a shell alias. So anyway, that's Terraform under the hood. So I'm going to run Terraform plan, and we're going to hope that the internet works. The internet works. Congratulations. Good work to the conference organizers. I'm just kidding. I'm tethered to my phone. I don't trust conference internet. I've done this before. So here you can see that Terraform has this description of the plan. And this plan only has one resource, but at the very bottom here, you'll notice it says, well, you probably can't see it because there's a sponsor sign in the way, but it says 1 to add, 0 to change, 0 to destroy. And there's this information here. And the green plus sign and the Google Compute address is Terraform saying, hey, I'm going to create this resource. And there's a bunch of things that look like HTML computed tags. That's Terraform's way of saying, hey, this is something that Google Cloud is going to generate and give back to me. I'm going to store that so I know it in the future, but right now, I don't know what those values are. You'll notice that the name and the region, though, so there's Atlantis Terraform demo and US East 4 are hard-coded, and that's because I gave those as values. So Terraform knows those in advance. So I'm working myself on my local laptop, maybe managing my blog. So my workflow is I ran Terraform plan. That looks great. I'm going to run Terraform apply. And this will take a second. So it's asking me to confirm. So this will take a second. This is actually under the hood making API calls to Google Cloud to generate this address. It's an IP address that's publicly accessible. Within seconds, people will try spamming it to see if it's vulnerable to the new Drupal vulnerability. Literally within seconds. If I pull up the logs, I guarantee you it's already being crawled. It's so crazy. So that took about 10 seconds to create this. That used the API under the hood. I could have used the UI for this, especially if I'm just one person. But imagine you're managing tens of thousands of servers. You can't really use the UI or even the API for that. You need a tool for managing that complexity. The challenge was, what if I mess up? There's no one here to check my work, and this talk is about collaboration. So how do we collaborate? Well, there's a number of platforms for collaboration, tools like GitLab and GitHub and Atlassian Stash. Today I'm going to show you GitHub, but the tool I'm going to show you also integrates with GitLab. So cool. It's also open source. So the tool I want to talk about is Atlantis. How many people have ever heard of Atlantis? You've never heard of it. It's a lost city. I'm joking. So I'm going to go to GitHub, and you get to see how terrible I am at typing. I have notifications. So this is GitHub. This is a private repo I created. Let me make this a bit bigger. And I have this service called Atlantis running. It's running in GKE, which is Google Kubernetes Engine. But it's just a single static Go binary. You can run it anywhere. You could run it on Heroku if you really wanted to. And what it does is it's a webhook. So whenever someone comments or opens a pull request, Atlantis is actually going to run Terraform as a service. So it's going to run Terraform plan and Terraform apply for us. And there's a bunch of checks and policies I can put in place. So I can say, don't allow an apply until someone has approved a pull request, for example. So that would mean that you can't actually provision infrastructure until someone else from your team comes on and clicks approve on the pull request. So let me show you what that looks like. So I'm going to go ahead and open up this main.tf file. This is the same file I just showed you locally. It's just also up on GitHub. I'm going to edit this file in the web UI. And I'm going to change the name of this from Atlantis Demo to Atlantis Terraform Atlanta Demo. And I will create a pull request with these changes. So I'll go ahead and create a pull request. And what you'll notice is that unlike the Travis CI integration or other GitHub webhooks, Atlantis doesn't immediately run Terraform plan and Terraform apply. And the reason for that is that infrastructure as code is highly collaborative. So people might want to come in here and we might want to make changes and we might want to do things, and we don't want to run Terraform every single time that happens. So someone might come in here and say, this looks wrong, etc. I apparently can't approve my own review. Who knew? But we might have a lot of collaboration going on here. And I'm one person, and this is a private repo, so you all can't participate. But you can imagine that on a long change set, we might see lots of people collaborating, we might see a lot of changes. And eventually we get into a point where we're like, okay, I would like to run Terraform. So I could have every single one of my developers have Terraform installed locally, make sure that they have all the things in sync, make sure it's always the same version. Or I could use a hosted open source service like Atlantis. So what I can do is right in here is actually type Atlantis plan and hope that the demo works. Ah, look, it's working. So what Atlantis does is it actually looks for the keywords. It has permission to read the conversation. And when you tell it plan, it's actually kind of like a chatbot in a GitHub pull request or a GitLab pull request. And it runs Terraform plan for me. So if I scroll up here, you can see it actually put a diff. That same output we saw in the terminal is now in the pull request. So there's a few advantages to this. The conversation is in one place. 3 years from now, if we go back and look, why was this change made? Not only do we have the change, but we have the Terraform plan and apply output. Additionally, the team can now look at this and say, yeah, I don't know if that looks right. For example, you might see that there's this new resource required. That's Terraform's way of saying it's going to delete the old IP address and create a new one because you're changing the name of the IP. So if we have things that are hard-coded to that old IP address, someone from the ops team might come in and say, hey, that's a bad idea. We shouldn't do this. And that's why separating the planning phase and the applying phase is important, because if we just straight up applied it, we'd find that out retroactively via monitoring or worse, via Twitter, and then you have to go back and fix it. So let's say this looks good to me, and I'm the only person on my team, so I can do that. I can actually run Atlantis apply directly from this pull request as well. And this one will take a little bit longer, because it took longer locally. This will actually run Terraform apply. And the Terraform apply is going to take a little bit longer because it's going to delete the old IP address reservation. Then it's going to create a new one. So we're looking at about 20 to 30 seconds instead of 10 seconds as before. But eventually, it will come back and it will put the output of that apply on this page as I waste time and walk back to my laptop slowly. Oh, look, it's here. So you can see here that the deletion of this resource took about 11 seconds. And then I created a new one about 11 seconds later. Now this is done, I can actually go into Google Cloud here and show you that I have this Atlantis Terraform Atlanta demo that we just created. This actually was created. We can delete it and recreate it if we want to, but it actually exists. So now that that's applied, I'll go ahead and merge this pull request, and now all of that is in sync. So obviously, I'm one person doing a demo, but you can imagine how this would be exciting if you were collaborating on a team, especially on like large infrastructure projects. My blog, for example, is about 30 or 40 resources. So regular, normal, mainstream infrastructure could be hundreds or thousands of resources with Terraform. So that is all I have for you, except this one slide that tells you where to find all of these things. So Terraform is terraform.io. Atlantis is atlantis.run, or just Google Atlantis, because sometimes that website is down. It's not my project. It's a third-party project by Hootsuite. But it's on GitHub. And then you can check out Google Cloud at cloud.google.com. That's my Twitter handle in the bottom right corner. Thank you.